2011 SEC Set A Paper 1. Okay, so we're just going to start off here. First of all, a prime number is a number that has two factors only, the number 1 and the number itself. Okay, so example of prime numbers, number 1 isn't actually included. Okay, so what it is, example of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and it just keeps continuing forever. Okay, so the next thing we gotta do is we gotta express 2652 as a product of prime numbers. What this means is that we basically got to break it down into its factors. A factor is something that it can multiply into or divide into equally. So it's an even number. Let's start off with dividing it by 2. So it's going to be 2 multiplied by 1326. Let's break up to 1326. We use the number 2 again because it's an even number, so that'll break up into 2 multiplied by 663. Now the two 2's are prime numbers, but the 663 isn't. So what we're going to do next is we're going to basically change 663. We're going to use 3, which is next on the list, and break it up. So 2 multiplied by 2 multiplied by, it's going to be 3 multiplied by 221. Next thing we gotta do is 221. So 221 equals 3 times 221 equals 3 multiplied by so we gotta check these prime numbers now to see what divides in. 3 won't divide into 221, 5 won't divide into 221, 11 won't divide into 221, but 13 will, and it goes in 17 times. And what we realize is that 13 and 17 are actually both on a prime number list. Okay, so what's going to happen next is we're going to multiply them, put in our original number. So we now know that 2652 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 13 multiplied by 17. Okay. The number 2 to the power 61 minus 1 is a prime number. Using your calculator, otherwise express this value to two significant figures in the form a to the power 10 to the n. That basically means scientific notation, okay? And a has to be in between 1 and 10. Okay, so a has to be in between 1 and 10, and element n means that a has to be a natural number. Example 2, 3, 4, 5, 6, 7, 8. So what we're going to get here is we're going to first of all put it into scientific mode. So we're going to press shift, the setup button, which is the same button as the mode. Then we're going to go for number 7, which is scientific mode, and then we're going to press 0, which means the amount of numbers. Put this number in the purple bubble into your calculator, and what you're going to get is 2 to the power 61 minus 1, and that is going to be equal to 2.30584 by 10 to the 18. Now 2.3 is the first two significant figures. Therefore, what's going to happen next is we're just going to get rid of the rest of the numbers, so our answer is going to be 2.3 by 10 to the power of 18. Okay. Now, the next part is use your answer in part C to say how many digits there are in the exact value of 2 to the power of 61 minus 1. So I want to introduce you to here is the concept of, let's say 3611. Okay, not the number asked for, but a different number. This number has 4 digits. Okay, if we're to put this in scientific notation, it's 3.11 by 10 to the 3. Note the 3. Okay, this 3 here tells you how many digits you might have. Just add 1 onto that power and you'll find out how many digits you have. So an example would be, we know that's 3, add on 1 to it and you get 4 digits. Let's take the last answer, 2.61 to the power 61 minus 1, 2.3 to the power of 10 to the 18. Now we have 18 in the power this time, add on 1 and that means we have 19 digits. Okay, and if we're to write it out, that's how big our number would be. Okay, 19 digits. Okay, next one. A certain deposit account will earn 3% interest in the first year and 6% interest in the second year. The interest is added to the account each year. The person invests €20,000. €20,000 is the principal. How much would he have in the account at the end of 2 years? What I like to do is I like to draw a table. Okay, so this says start. That's meant to say end. We'll fix that in a minute. Okay, so this is going to be year 1 and year 2. Now at the start of year 1 we have €20,000. Okay, €20,000 is 100% at the start of year 1. We're going to make it bigger. We're going to turn 100%, we're going to add on 3%, and what we're going to do is we're going to turn it into 103%. So to find 103%, what we basically have to say is that 100% equals 20,000. So we're going to divide by 100 to find 1%. To find 103%, we then have to multiply by 103. So divide 20,000 by 100, multiply by 103, and what we'll get is 20,600. 20,600 is how much we have at the end of year 1, and also at the start of year 2. 20,600. Reset again. At the start of year 2, 100% is 20,600. In year 2, we're going to add on 6% interest. So to add on 6% interest, what we're going to end up with is 106%. Okay? So once again, to change 100% into 106%, we're first going to divide by 100, then we're going to multiply by 106. Okay? So divide by 100, and then multiply by 106, and what we'll get here is 21,836. Okay? So, next part onto that. Okay, now the interest made, we aren't asked for this, we're just asked for the total sum of the question, but the interest made is basically how much did we start off with minus the end amount. So we started off with 20,000 at the start of the 2 years, therefore the total interest is 1,836. Next question. Show that to the nearest euro, the same amount of interest is earned by investing the money for 2 years in an account that pays compound interest at 4.49%. So we had to find out the same sort of question, this time with the same interest every year. So what we can do is repeat part 1. Okay, so we want to make sure that our answer is 1,836. Okay, so we're going to draw our table again. And what we can do is year 1 and year 2, start and end. Year 1, year 2. Now we have 20,000 to start of year 1. This is 100%. We're going to add on 4.49% onto it. So what's going to happen is we're going to add on 4.49%, and what's going to happen here, we're going to have to divide by 100. So 20,000 divided by 100, multiply by 104.9, 104.49. And what we're going to get here is 20,898. Now, what is at the end of year 1 is also the start of year 2, which is 20,898. So what we're going to do next is reset. At the start of year 2, this is 100% of what we have at the start of year 2. Once again, we're going to add on 4.49%. So it's going to end up to be 104.49% underneath. Okay. So what's going to happen next is we're going to basically we're going to multiply, get to 20,898. We're going to divide by 100 and multiply by 104.49. When we do this, our answer is 21,836.32. We have to find out how much interest is made, so we're going to round it off to the nearest euro, ignore the 32 cent, and then we're going to put it in, take away the 20,000, and we will get 1,836 euro, exactly the same amount. Now, a different way of doing this question would be only for compound interest, by the way. This will only work for compound interest, where the interest is the same every year. There's a formula where F is the final sum of your money, P is the principal, the amount you invest in the first place, I is the interest in decimal form, and T is the amount of years. So for example, in this question, what we're going to do is we're going to get our interest of 4.49, its percentage. We're going to divide it by 100 and change it into decimals. Then, after changing it into decimals, we can now put it into the formula, where the principal is going to be 20,000, I is going to be 0.0449, and T is going to be 3 years. Or sorry, 2 years. So put that into your calculator, exactly as it looks, in the purple bubble there, and what we'll also get is 21,836.32. The exact same method, bit shorter that way, but then again it only works if the compound interest is the same for every year. Now, next one. The terms in our arithmetic series are given by the formula Tn equals 38 minus 4n for n equals 1, 2, 3 and 4. Write down the first three terms in this sequence. So the first three terms are T1, T2 and T3. Now please remember, for T1 n equals 1, for T2 n equals 2 and T3 n equals 3. We're not asked for T4, but I'm going to do it anyway just to see the trend, okay? So it's 38 minus 4 times 1, 38 minus 4 times 2, 38 minus 4 times 3 and 38 minus 4 times 4. Now what you got to remember is we're just replacing in the end value for each one. So what we're going to get is 38, 4, 30, 26 and 22 when you put them into your calculator. What we can see from this is that the starting off number is 34, so A equals 34 and the common difference is minus 4. It's going down minus 4 every time. So we can see that A is 34 and the common difference is minus 4. Okay, next question. What is the first negative term in the sequence? What we can do here is we can write down all the numbers. So we know that T4 is 22. Just keep taking away 4 until you reach the first negative number, which is minus 2. So this one here is T4, that's T5, this one's T6, this is T7, that's T8, this is T9, T10. It's the 10th term. So T10 is minus 2. Okay. Another way of doing it would be to write down the general term, which is 38 minus 4n. You could say that this has to be less than 0. It has to be a negative number. Solve this inequality where 38 is smaller than 4n. Change sides, 40n, or spin around. 40n must be bigger than 38. Therefore n is equal to 38 over 4 and n therefore is 9.5. Now the thing about n's in sequences and series is n can never ever be, it has to be a whole number. So therefore it has to be the 10th term in the sequence because it has to be bigger than 9.5 and the first number that does that is n10. It's another way of getting the same answer. Now next one. Find the terms of the first 15 sums of the sequence. What we can do here is n over 2, this is the general format, 2a plus n minus 1 times d. Okay, s of n therefore is 15 over 2. We know that n is 15, we know that a is 34 and d is minus 4. Keep continuing, a is 34, d is minus 4. 2 times 34 gives you 68. n minus 1, 15 minus 1 gives you 14. 14 times minus 4 is minus 56. Put all of this into the calculator and what we get is our answer is 90. So the sum of the first 15 terms added together is 90. Next question. Find the value for n for which the sum of the first n terms of the sequence is 0. Once again write down the formula for s of n. Once again we don't know the value of n this time because find the value of n is what we're looking for. Therefore we do not know the value of n. So what we can say is once again a is 34, 2 times 34 is 68, d is minus 4, multiply in minus 4 by n minus 4 and what we get is 4 minus 4n plus 4 and this breaks down into, well this has to be equal to 0 and what this will break down is n over 2 into 72, 68 plus 4 is 72 minus 4n. And this all has to equal 0. Now we can get rid of the 2. So we can divide 72 by 2 and then divide 4n by 2 and then we have 36 minus 2n. Now when solving this equation equals to 0, what we have to do is either the first number equals 0 or the second number equals 0. So either n equals 0, which doesn't work because the first term is n equals 1, or 36 minus 2n equals 0, which is the second number here in the brackets. And what can happen there is 36 equals 2n, and therefore must be equal to 18. Next question. Solve the simultaneous equations. Now, you notice that there's no squares in either one of them, but there is fractions. So in order to get the fractions, we gotta get rid of the fractions. So the first one has thirds. So what we do is need to multiply both sides by 3. Now the reason we're allowed to do this is if you imagine the following equation, 2 plus 3 equals 5. You have to multiply each side by the same amount. It's like a weighing scale. So I want to multiply each side by 3. I'd get 6 plus 9 equals 15. So we got to take the same principle in here. So 6f. So 3 multiplied by 2f is 6f. 3 multiplied by 2 over 3g is 2g. And 3 multiplied by 1 is 3. The next step we got to do is got to move the 3 over to the other side, and that's our first simultaneous equation. For the second equation located here, we have halves. So we got to get rid of the halves by multiplying by 2. So 2f plus g, so 2 times f is 2f, 2 times a half g is g, 2 times 1 is 2. Bring over the 2 over the other side, and we got 2f plus g equals minus 2. Okay, next one. What we got to do in a simultaneous equation is we got to look at this as like a magic mirror. The bottom formula, which is here, sees the 2g. So you got to multiply the bottom formula by 2, and the 2g here sees 1g. So you got to multiply the bottom one by 1, top one by 1. And what happens is we multiply these out. The top one stays the same, and the bottom one changes. So we get 4f plus 2g equals minus 4. Now, when you add them both together, the g's still don't cancel. So what we need to do is we need to change this 2g into a minus 2g. So if you imagine we had the following equation, 2 plus 1 equals 3. Now what we know about 2 plus 1 equals 3 is that if we multiply both sides by minus 1, we could get minus 2 minus 1 equals minus 3. So remember, when you multiply one side of an equation by a number, you must also multiply the other side of the equation by the same number. So we're just going to go in here, multiply everything by minus 1, change the signs, add directly down. 6f minus 4f is 2f, minus 3 plus 4 is 1. Now remember, 2g plus 2g minus 2g is no g's, so we know that f equals a half. Okay, so f is going to be equal to a half. The next one, we're going to put it up here. So we're going to get is 2 times, we're going to use this formula here to find out what g is. So 2f plus g equals minus 2. Replace f with a half, plus g equals minus 2. 2 times a half is 1. 1 plus g equals minus 2. Bring the 1 over the other side. So you get g equals minus 2 minus 1. G therefore will be equal to minus 3. Next question. Question 5. Z is a complex number from complex number 1 plus I, where I squared equals minus 1. Find Z2. Now what Z2 is means 1 plus I by 1 plus I. So what we're going to do is just going to multiply these out. Anytime we see an I squared, we're going to replace it with minus 1. So 1 times 1 is 1. 1 times I is I. Okay, so we're just going to, it's first number, second bracket, second number, second bracket. Now we're just going to multiply this out. 1 multiplied by 1 is 1. 1 multiplied by I is I. Okay. 1 multiplied by 1 is I. I multiplied by I is I squared. Now that I squared can change into a minus 1. So then when we add them both together, we get 2i. Next one. Z squared. Z cubed, is the same thing as what we did before, except there's one extra bracket at the end. However, in the first question, we know the answer to when we multiplied two brackets together because we already did it over here. We know that the answer is 2i. So all we have to do is multiply 2i by 1 plus I. And what we'll get is 2i plus 2i squared. We know that 2i squared here is minus 2. So then we can read our answer here, minus 2. So we know that it's going to be minus 2 plus 2i is Z cubed. Now, for Z to the power of 4, what we're going to use is Z4 is the same as Z squared multiplied by Z squared. In the same way, X4 is the same thing as X3 multiplied by X1. So all we got to do is put in the answer for Z2, which is 2i, multiplied by the other 2i here. And what happens when we multiply 2i by 2i is we get 4i squared, and 4i squared is minus 4. It's easy as pie. Next one. We got to draw all these on the Eragon diagram. Now what you need to remember about the Eragon diagram is that basically the I values are like the y-axis and the real numbers are the x-axis. So an example would be for Z, we know that the imaginary axis is the y-axis and the real axis is the real numbers there. Okay, so the real number for Z is 1 and the imaginary number for i's is 1i, so it's going to be the point 1, 1. So that's the real, so it's going to be 1, 1 for Z. The next one is Z squared, which is 2i. that has no real number, but has two imaginary numbers, as in 2y. So 2y, so it's going to be 0, 2y, and that's going to be z squared. The third one has a real and an imaginary number, so it's going to be minus 2 on the x-axis, plus 2 on the y-axis, which gets you z3. Now z4 is basically only minus 4, no imaginary numbers, so there's no only real numbers, so it's going to be minus 4. Now, question part E makes one observation about the pattern of points on the diagram. What I ask you to look at is look at the distance from the origin of each one. As the powers get bigger, so does the distance from the origin. Okay? So what's going to happen here is, as the power of z gets bigger, its distance from the origin also gets bigger. Okay? That's the answer to that section there. Now, by using Z4 or otherwise, find the values of Z8, Z12 and Z16 and insert their values into the table below. Okay, so to get into the table below, what we're going to do is just going to do it here. Okay, so look, this formula comes from your tables. A to the m to the power of n is equal to a multiplied by m to the n. So an example of this would be, if I was to write down z4 to the power of 2, the answer is z8. Therefore z8 equals z4 to the power of 2, z12 equals z4 to the power of 3, and z16 equals z4 to the power of 4. So we get minus 4, because we know that z4 is minus 4, so minus 4 squared is 16. Therefore z8 is 16. Okay, and we know that z12 is minus 4 to the power of 3, which is minus 64. Okay, and we also know that z4 to the power of 4 is going to be minus 4 to the power of 4, which gives us minus 256. Now what we got to do is just fill in this table here. 16 minus 64 and 256. Based on the pattern of values or otherwise, state whether Z40 is positive or negative. So the pattern of values, if you look at it, Z4 is minus, Z8 is plus, Z12 is minus, Z16 is plus. Okay, so what we got to do is we got to count downwards. Okay, and what we got to do is figure out whether it's negative or positive. So what we could do is we could just keep changing the values. 12 is positive, 16 is negative. And we could say, just keep changing it, and we'd eventually find out that Z40 is positive just by going through just like a routine of 4 is just gaps of 4. 4 is negative, 8 is positive, 12 is negative, 16 is positive. Work it all the way down to 40. Another way of doing it would be to use your rules of indices again, where Z40 is Z4 to the power of 10. And what we know about Z4, it's minus 4. Put it into the calculator, and we know that it equals a positive number, and the answer being 1,048,576. Now, next thing we got to do is write Z40 as a power of 2. Quite a difficult question, this one. Okay, so quite a difficult question. So what we got to do is Z40 equals Z4 to the power of 10. Okay, and Z4 to the power of 10 is going to be minus 4 to the power of 10. Now, if you imagine we had 2x to the power of 5, the way I'm allowed to do this is I can break up the 2x in the middle. I can say it's 2 to the power of 5 multiplied by x to the power of 5. Okay, and what can happen next is basically I can break it up in the same way. I'm going to break minus 4 up into minus 1 and 4 to the power of 10. And minus 1 to the power of 10 is 1. And now I'm left with 4 to the power of 10. Now 4 to the power of 10 is basically, I got to change it as a power of 2. So 4 changes into 2 squared. 2 squared to the power of 10 is 2 squared to the power of 10, which is 2 to the power of 20. So we know that Z40 is 2 to the power of 20. Okay. Next part, we got to find Z41. Z41 is basically Z40 multiplied by Z1. Once again, it's this rule. A to the power of m plus n is am multiplied by an. So, i.e., Z to the power of 41 is Z40 multiplied by Z1. Because when you add them together, you get Z41. We know the answer for Z40. It's in the same way that x to the power of 5 is the same thing as x cubed multiplied by x squared. So what we're going to do is we're going to say that Z40 is Z20, is 2 to the power of 20. Z40 is 2 to the power of 20. We know that z is 1 plus I. Multiply them out. 2 to the power of 20 plus 2 squared, 2 to the power of 20i. Now, to draw this on an Eragon diagram, what we first have to realize is what would we do if the question was really easy. If we had 3 plus 4i, for instance, okay, and we were to plot this down on a graph as shown, 3 across, 4 up. The rule is for the length of a complex number is that if z is a plus bi, then the length of z is square root of a squared plus b squared. In normal terms, whatever the real number is, put it in and square it. Whatever the imaginary number is, put it in and square it. Add them together and square root. Okay? And what we can get here is 3 squared plus 4 squared, square root it. This means that this line in question, which is 3 plus 4i, is a distance of 5 away from the origin. We got to do the same thing for this Z41. Okay? Now, for Z41, what we're going to do is we know that a is 2 to the power of 20 and b is also 2 to the power of 20i. So replace a, we're going to draw it out now, 220, 220. You're going to find the distance from this point to the origin. So what's going to happen is we're going to put it in. So 2 to the power of 20 squared plus 2 to the power of 20 squared. And what we can get here is it's going to be 2 to the power of 40 using the rule as before. Okay, so the rule on top here, we used it before, right? So it's going to be 2 to the power of 40 because you multiply the 20 by the 2. The other one is also going to be 2 to the power of 40. Then you're going to add them together. 2 to the power of 40 plus 2 to the power of 40 is 2 times 2 to the 40. And if you remember the rule, we got to add these together now because they're being multiplied by each other. It's going to be 2 to the power of 41. So remember the rules. am multiplied by an is am plus n. Therefore, that's going to be 2 to the power of 41. And the next thing we've got to realize is the square root sign means a to the power of a half. And if there's already a power inside there, it's going to be a to the power of m divided by am over 2. And what that's going to give us is 2 to the power of 41 divided by 2. That's our answer, okay? Now,